I am a Microsoft MVP for the SQL Server product. I am a Microsoft Certified Master for SQL Server 2008 and SQL Server 2012. I am a VMware vExpert. I am an EMC elect, and I have been a Microsoft Certified Trainer. So basically, I spend way too much time standing in front of audiences giving presentations and not enough time actually working. So here's what we're going to talk about over the course of the next hour or so. We're going to basically be talking about the high availability and disaster recovery options within SQL Server 2014. And then we're also going to talk about some of the new features that are coming, some of the enhancements that are coming in SQL Server 2016 when it gets released. So we're going to start with always-on failover clustering. So we may know that more as traditional failover clustering. We're going to talk about always-on availability groups. I'm going to try and move and not piss off the speakers. And then we're going to talk about, again, like I said, SQL Server 2016. So when you are setting up your traditional failover clustering, your always-on failover clustering solution, we are actually just building that on top of the Windows failover clustering technology that's been built into Windows for 10, 15 years now. So the reason we're building on top of a Windows technology as opposed to building everything ourselves within the SQL Server product is that it doesn't make sense for the SQL Server product team to spend a lot of time and a lot of money building components that some other team at Microsoft has already built. If we look at database mirroring, which was introduced back in SQL Server 2005, one of the things in database mirroring that was really annoying that I didn't like too much about it was the fact that we had this witness server that we had to run that would do the failover detection and the failover triggering. Well, Microsoft SQL Server team did a good job with that, but the Windows clustering team has an actual better job, building that sort of thing, because that's what they've been doing for 20 years. That's all they do. So instead of building their own features to do that, they're simply leveraging features that already exist. So with failover clustering, when we set it up, we have a single set of database files. So we have just one set of database files, so we don't have to waste a lot of storage holding multiple copies of the data. That's one of the big advantages to failover clustering over some of the legacy technology, or some of the either legacy or newer technologies. The other nice thing about the fact that it only has one set of database files is we're not managing huge numbers of files. We're not spending a lot of money on all this, storing all this information. We can also, because we've just got the one set of database files and we're doing a failover cluster at the instance level, we can host as many databases in there as we need. Things like always-on availability groups have a limit of 100 databases per availability group configuration within the environment, within one set of availability groups. We don't have that with failover clustering. However many databases you need to support in a database instance, you can support with failover clustering. It supports hosting all 32,000 databases if you need a system set up like that. I would not recommend putting a database server with 32,000 databases, just to be clear. Basically, what we're configuring when we set up failover clustering is multiple servers, each with an instance of SQL Server on it, all pointing at those same database files. So we just configure it so that only one of those machines is running that particular instance at any one time. In the event that that server fails or we need to move that instance from one physical machine to another, we simply tell it to fail over, and the ownership of all those resources, the resources being the disks and the database instance, simply move from one instance to another, or one machine to another. So the basic configuration looks something like this. We've got two nodes. In this case, we've got node A, node B. We've got some shared storage on the bottom down here. And then we've got our Windows failover cluster network name kind of sitting on top of that. We've got a database instance that's running. And so when we need to move things around, so if we need to, for example, fail node A or reboot node A for some reason, we can simply just move all the databases right over to node B. The amount of time that the end user is down, it varies from server to server, but it's typically somewhere in the 30 to 60 to 90 second range, somewhere in there. It's fairly quick to fail things over. Basically, all we're doing when that failover happens, stopping the database, stopping SQL Server, changing ownership to the other side, and restarting it. The amount of time it's going to take to shut down and restart is going to be totally dependent on the workload on the box. I've seen servers turn off in as fast as a few seconds. I've also seen them take a few minutes to turn off because they're running really, really big workloads. One of my clients has an incredibly large server. It's got 80 cores, a terabyte of RAM, and it takes about 4 or 5 minutes for it to actually just shut down and then for the failover to happen, and then it's just a matter of waiting for SQL to start like it normally does. We can also scale out and do a larger multi-node or multi-instance failover cluster across a larger number of nodes. We do this simply by getting more pieces of hardware, either more physical servers or more virtual machines, and just building a wider cluster, and then configuring multiple SQL Server instances on there. So then we've got a much wider system, but it's also actually less expensive for us to build this way. In the two-node configuration here, we've actually got 50% of our hardware not doing any work. So this is a 50% expenditure for basically nothing, for protection. If we go with a wider cluster with more instances on it, now we've got 3 instances running on 4 pieces of hardware. Now we only have a 25% hardware waste. If we go even bigger, we scale it even wider, we can get even better utilization of that hardware. So we can actually get 16. So SQL Server installer takes about 45 minutes to an hour to run. Then you've got to patch all these machines, so you're looking at about 2 hours per install. You're looking at a good 24 to 36 hours of just installing SQL Server if you were doing this manually. Automation obviously can make this a lot faster. You can just click a couple of buttons, run a couple of batch files, install each machine, and it gets much smoother and much faster to do these installations. You're building these failover clusters. Each instance that we configure is going to have its own dedicated network name and its own dedicated IP address. So this is a requirement from failover clustering because each of these instances fails over independently from each other. So because of that, we need to make sure that each one's got its own name and its own IP as things are moving around, because we can't have anything relying on anything else. So looking back at this instance, that means that each one of these SQL instances is going to have its own network name and its own IP address. So these are all probably going to be named instances, but the instance name isn't unique enough for us because those instances could be running on different pieces of hardware. If they shared a network name, they'd have to share a piece of hardware, and we don't want anything reliant on anything else. We require at least one set of shared disks somewhere. That shared disk can be either clustered storage, so SAN storage that's presented. It can be presented over iSCSI. It can actually be on a network share now. Starting in SQL Server 2014, we have the ability to create our failover clusters with all their system databases on shared storage on a network drive. So we can use SMB network shares to store our data file. All we need to have is some sort of shared storage. At this point, it doesn't really matter what it is, as long as it's accessible by all the machines at all times. So when we're configuring all these things, we need to keep a few things in mind as far as how everything is configured within these failover clusters. The big thing is we're no longer binding an instance to a machine. So we need to kind of rethink how we define instance in our mind, the SQL Server instance in our mind. Because it's not just tied to this one piece of hardware or this one VM anymore. It could be running on any of the machines in the environment. So we need to make sure that we're thinking about the fact that it could be running anywhere. I've actually seen people set up Windows failover clusters and SQL failover clusters where the SQL Server and the application only work correctly if SQL Server is running on a specific node of the cluster. Maybe they'll have a 2-node cluster. It always works on node A. The application won't work if it's on node B. That's kind of a pointless configuration because the application has to work. The whole point of this isn't to keep the database online. It's to keep the application functioning and the business making money. So we've got a lot of instances that have to be configured, and we've got to configure some things just right, and patching also obviously becomes a little more interesting when we're doing this, because we now need to roll these patches out over and over and over again just to get this one instance patched. Thinking about the diagram I had before with the 4 machines, if I want to patch one of those instances to Service Pack 1, I've now actually got to install Service Pack 1 4 times, because I've got to push it out to each one of those boxes for that specific instance. When we're setting up the failover clusters, inside Windows failover clustering, we set up dependencies to make sure that things are starting in the right order. All these resources have to come online, and these resources are the services, the disks, the IPs, and the network names. If things aren't coming online in the correct order, services aren't going to start correctly. For example, if we try to bring the SQL Server service up before the disks have started and before the disks have become available, obviously SQL Server is not going to work, because SQL Server cannot start without things like the master database. So we have to build dependencies within the failover clustering. Now, fortunately, when you do the initial SQL Server install, it's going to set up all these dependencies for you right out of the gate. So it's going to, when you install it, it asks you what IP you're going to use, what network name, what hard drives. So it'll build all those dependencies for you. But as time goes on, you may need to add additional hard drives. You may need to add a new IP address if you've got an additional network segment that you need to be able to support for some reason. So you need to make sure that you know how to actually add in these dependencies after the fact and make sure that these dependencies are set up correctly, especially if you're using mount points because you've got more than 25 drives that you need to mount to a server. Maybe you've got a really high load application that needs 100 hard drives mounted to it. Obviously, we don't have 100 drive letters. So we have to use mount points to get those mapped correctly. And the installer does not set the mount points up correctly when it's doing these dependencies. So you may have to go modify those dependencies to get things working exactly as they should. So when you're setting up these dependencies, the IP address is going to, sorry, the network name is going to be dependent on the IP address. The SQL service is going to be dependent on the network name and then the hard drives. And then the SQL Server agent will be dependent on the SQL Server service. That's the basic set of dependencies. There's actually not that many of them to work with. There were some enhancements to failover clustering that were introduced back in SQL Server 2012. So before I keep going, who's running SQL Server 2016 today? Nobody. Okay, 2014? Wow, 2/3 of the audience. Okay, 2012? This is where you guys get your exercise. All right, basically everybody. 2008 R2. Pretty much everybody. Okay, 2008. Most everybody. 2005. This is where the hands go down. 2007. 6, 5. What? 3, 4, 5. Wow, that I'm so sorry. 4.2. Anybody that old? Nothing that. Okay. So, that's 5 people running 6.5. That is unfortunately a record. So, in SQL Server 2012, we actually added in some new enhancements for failover clustering. We actually got a lot of really cool features for clustering in 2012. So the first one is the multi-subnet failover support. Has anybody here ever been a network engineer before? A couple of people maybe? Okay. So one of the really annoying things about doing multi-site failover clustering in SQL Server 2008 and below was you had to build what's called a stretch subnet or stretch VLAN. Basically, you've got 2 data centers, one in city A, one in city B, and they have to have the same IP subnet in them. This is actually shockingly hard to do. Most network engineers can't do it unless they're really, really good, and they have a lot of help from their network vendor. So we don't have that requirement anymore. We threw that requirement out with SQL Server 2012. So we can now set up multi-site failover clusters and have 2 IP addresses, one for each network site. Makes it much, much easier to get these things up and running. We already talked about the network storage support. If you are in an environment where you want to get every last % of CPU power out of your SQL servers, you can install SQL Server in Windows Core Mode now. Windows Core Mode is a GUI-less or a graphical user interface-less installation. So basically, if you remote desktop into the server, all you get is a command prompt. Basically, looks like a Linux box. This gives you every little bit of processing power possible. It also minimizes the number of things you have to patch on the server. Up through 2008 R2, we did not support installing in this method for failover clusters. We did starting in 2012. One of the things I really like and that I use a lot actually up in Azure is putting tempdb on local disk. So up until 2008 R2, anytime we built a failover cluster, every database had to be on shared storage. Starting in 2012, we could put tempdb on our local C drive or D drive or any of the local non-clustered drives. In Azure, this is really handy because the D drive on every single virtual machine in Windows Azure is high-speed SSD storage. So you can always put your tempdb on local SSD storage.